Hello everyone. Last class we have seen about classical free electron theory, postulates, merits and demerits. On this class we are going to see about band theory of solids. The understanding of band structure is very essential if you want to understand well about the conductors, semiconductors and metals. So in this we are going to see about the energy levels, forbidden energy gap of conductors, insulators and semiconductors. So we are seeing the electrons and shell. Now we are seeing an atomic cell energy level. You can able to see the shells K, L, M, N, and you can able to see the electrons or electrons uh, in the K shell. K shell have 2 electrons, where L shell have 8 electrons. M is having 18 electrons, while N is having 32 electrons. You know that formula 2n squared. So if you substitute N for K shell, you have to substitute N. For L shell, you have to substitute 2. For M shell, 3, N, 4, etc. So this will give you the shell in which electrons will orbit around the nucleus. Okay, so what is energy levels? The energy levels, or the levels occupied by the electrons, are known as energy levels. Okay, see here, you can see that K shell having 2 electrons. So this 2 electrons will have the first energy level. Okay, and you can see L shell have 8 electrons. So this 8 electron will contribute the second energy level. And you can see the third shell M have 18 electrons, and this 18 electrons will contribute the third energy level, and it will go on. So what is energy level? Energy level is related to shells. Okay, K shell first energy level, L shell second energy level, like that it will go on. And this is the flat band diagram. That is, 1 correspond to the first energy level, 2 correspond to the second energy level, 3 correspond to the third energy level, and it will go on. And you can see all the energy levels are quantized. That is quantization, in the sense we have only allowed energy levels. We won't have a continuous energy levels. We have only allowed energy levels. See, you don't find any energy levels in between 1 and 2. So you can say that first energy level and second energy level is discrete, or you can say it is a quantized. So quantized in the sense you have only allowed energy level, not continuous energy levels. So this is the flat energy levels, or you can say flat band diagram, or we are not, since we are talking about energy levels, you can say this is the energy level. The energy level near to the nucleus is the first energy level. Second energy level somewhat far apart. Third energy level is somewhat far apart, and it will go on up to 7 energy levels. But in real, we have millions of energy level. If you consider a material, the material consists of millions of energy levels. Okay, so this is the differentiate between energy levels. So each energy level correspond to the each cells. Okay, so the cells K shell, M shell, K, L, M, N, according to the formula 2n squared, like the electrons will arranged in that according to the formula 2n squared. So keep that in mind. The electrons occupy a level which is known as energy level, and energy level, so discrete, or you can say it is quantized energy levels, or quantized, that is, there is no allowed energy level in between two energy levels. Okay, so only we have allowed values. And now we will see what is valence band, conduction band and forbidden energy gap. Now you are seeing this is energy, and this correspond to wave vector k. Okay, x-axis correspond to wave vector k, y-axis correspond to band gap or energy. Okay, see, completely filled bands. What is bands? Bands are collection of energy levels. Okay, bands are collection of energy levels. You got it? Now completely filled band. So this inner bands are correspond to core electrons. Keep that in mind. This inner bands, which consists of so much number of energy level, corresponds to core electrons. And now we are seeing the valence band. The valence bands are correspond to valence electrons. Okay, and you can see this valence band, either it is fully filled or partially filled. It should be, okay, it is not completely, it is fully or partially filled. Okay, what is valence band? Valence band is the number of energy level which is occupied by the valence electrons. So that is known as valence band. Either it is fully occupied or it's partially filled. But if you see the inner bands, all are completely filled. But if you consider a valence band, either it's fully filled or it is partially filled. Okay, now the band which next to the conduction band, valence band, is conduction band. Okay, either it is empty or it is partially filled. Okay, it is partially filled in metal and it is empty in insulators and semiconductors. I will explain in the next slide. Okay, so the band which correspond to the, which next to the valence band is conduction band, and conduction band corresponds to the conduction of electrons, and the space between the valence band and conduction band is energy level, or you can say forbidden energy gap or forbidden energy band. Okay, so you can't able to find electrons over this forbidden energy gap, since we are talking about quantization and discrete energy level. So as I said in the before slide, all the energy levels are quantized, so you can have a discrete values. So here valence band is fully or partially filled, conduction band is above the valence band, and you have a space between the valence band and conduction band is known as forbidden energy gap. So now, how we can differentiate metal, insulator and semiconductors. Another important term I want to discuss is, seeing a term E suffix F. E suffix F is a Fermi energy level. What is Fermi energy level? It is the energy level occupied by all electrons at 0 Kelvin. So keep that in mind. It is an energy level occupied by the electrons at 0 Kelvin. Now you see metal. See here, you have valence band, you have conduction band. Valence band is fully filled while conduction band is partially filled, or you can say there are more number of unoccupied states in the conduction band. And see the maximum maximum energy level the electron occupies. So that tells you the Fermi energy level. So what is Fermi energy level? Maximum energy level occupied by the electron at 0 Kelvin. So this is maximum energy level. So in metal, Fermi energy level lies here. Okay, in metal, Fermi energy level lies here. So this is the Fermi energy level for metal. Okay, this is how you can able to differentiate a metal: fully filled valence band, partially filled conduction band, or you can say that both valence band, conduction band overlap with each other. If you consider a insulator, see the band gap, it is very high, it is more than 2 electron volt. So fully filled valence band, empty conduction band, and you can see the band gap is very high, it is more than 2 electron volt, and the Fermi energy level is in between valence band and conduction band, and this is the band structure or flat band structure of insulator. Okay, and you can see the semiconductor, it is valence band is fully filled, conduction band is empty, and you can see the Fermi energy level is between the valence band and conduction band. So the Fermi energy level is less than 2 electron volt, so we can say that it is a semiconductor. So see the Fermi energy level for metal, it is on the conduction band. For insulator, it is in between the valence band, conduction band. For semiconductor also, it's in between the valence band and conduction band. For the insulator, the band gap is very high. For the semiconductor, band gap is less than 2 electron volt. Okay, so this is how we can differentiate metal, insulator and semiconductors by using the flat band diagram. So in the next class, we are going to see about the Fermi-Dirac statistics. This explains you about the occupation of electrons in the energy level. Thank you.